Hi everyone, welcome to streaming one record of data at a time. We will begin shortly. We'll give a couple of more minutes to people to start, and then I will start. Uh, I see people from all over the world, and this is awesome. Oh wow. Okay, so welcome. Uh, and we are going to talk about streaming data one record at a time. We'll see how it works. We'll see why it is interesting, and we will talk a little bit about iterators and generics and filtering things with a query language and something known as HTTP chunked encoding that lets you also emit HTTP in one record at a time. So, if you're not familiar, my name is Miki Tebeka. I'm an instructor here at Other Labs. I also wrote a few books. I have LinkedIn Learning courses and Other Labs courses. I'm organizing meetups and conferences. Have open source projects, write code daily. Enjoy my life in a very geeky way. And what we're going to talk today is about something which is pretty new to Go, which is a range over function. And this came out on Go 123. So less than a year from now, we had range over functions. We'll see in a bit a demo and see how we can use it, or how you can use it in your code to save a lot of memory. But I'm also working with Python, and I'm working with Go for almost from the very beginning, I think 14 years. With Python, 25, 27 years. Python is 34 by now, so it is old. And in Python, we had generators since 2003. So it's the same concept. It's not exactly the same implementation. Some details are different, but the ideas that you get from things that are iterators that generate one value at a time are really interesting. And it's a different mode of thinking about programming, and it can help you out. So let's start by looking at what is an iterator in Go. You know what? Let's make it a little bit bigger. Okay. So, what is an iterator? So, you're probably familiar with the time.tick, which you can run a for loop, and then every iteration of the for loop, it sleeps for an amount of time. So, here's the current timer.tick is implemented with a channel and a go routine, but this is the version that's implemented with an iterator. So, basically, an iterator, what you're returning, is something known as iter.sec. It's a sequence or a name of a sequence. And in the square brackets, this is generics. We say, what is this sequence returning? And I'm returning time.time. And there's also a sec2, which allows you to return two values. And then you can return also error values or anything else that you want to do. So what is basically a sequence? Sequence is a function, right? We define a function. This function gets another function as an argument. Yeah, this is confusing, I know, but you define a function, you generate a function that gets a function as an argument. This is the yield function, and this yield function is the one that you pass values. So your function, the one I'm defining on line 11, is generating values, and every time it generates a value, it passes it to the yield function, and this is being passed to the user, and the user can do whatever they want. So basically what we're doing is an infinite for loop. We yield the current time, and then we sleep. Now, how do we know that the for loop ended, that the user hit a break or something like that? This is coming from this function that is being passed to us as an argument. It returns a Boolean value. And if it says false, it means that there is no more iterations, and then you can do cleanup and other things that you can do. So basically, iter.sec is a function that gets a function as an argument, and that's it. It doesn't do anything more. And this function, it basically feeds the values to it. Once you do that, you can run a follow-up on that, right? So I'm doing for time in range of tick for 1 second. I'm going to print out the time, going to increment I, and if I is bigger than 5, I'm going to break. And once I'm breaking, basically yield is going to return false on the last value, and then the iterator is going to exit. Right, then we can even run this, and you see that we have about a second difference, right? This is not a real-time thing, so we have about a second difference between each one of them. Okay, so not what I wanted. This is what I want. Okay, so this is briefly on generators, and I'm not going to go about the mechanics, but I'm going to start with a use case that we want to do, and then we'll see how we can use iterators, to leverage that. Sorry for mixing the terms. I'm working with a project now that has both Python and Go, and sometimes things sneaks from one place to the other. So I'll try to say the correct terms, which is iterators and sequences, but bear with me if I'm sometimes forgetting. So we want to log files from a disk so we can query them. And looking at the log files, we see that they are basically an old, ignore the time, right? I took some public data logs, so this is 1995, but these are Apache logs, and you need to parse them. They are not in structured logging, right? This is like a headache. But then, you think about it and you say, hey, there's this new kid around known as Gen AI, either Copilot or something else, and they're really good at doing regular expressions. That's what they're trying. And I'm went to Claude and asked Claude, write a Go regular expression to pass these lines, and it gives me some kind of a regular expression. But we never trust what these things are giving, because sometimes they hallucinate, and you need to be aware of that. So you always need to double check. So I went to this great site. It's called Regular Expression 101. It lets you write regular expression and data and shows you the matches in the data. Make sure to pick Golang on the left side. So the regular expression variant is for Go and not for another language. And it looks good. It looks like we're doing what we want. So we assume it's fine, right? I'm not going, this is not the heart of what we're trying to do, so I'm going to go over that pretty quickly. But two things. One is the regular expressions. There is a joke about regular expressions. A developer sees a problem and he says, I know I'm going to solve it with a regular expression. Now they have two problems. So we are going to use this regular expression. And the second thing is that throughout the code that you're going to see, I'm going to limit the error handling a lot, just to make it clear and to the point. As I said, there is iter_sec2, which you can return errors, then you can work with it. But as we'll see, when you deal with streams of data, sometimes we don't do errors. We send over values that signify errors, but we don't actually return errors, depending on how we want to work with it. Okay, so the first thing to look is the parser, right? So I have the parser, and the parser, the main thing that is really interesting here is the structure, right? I have a log structure, and I have something that parses a line. It gets a line, and return a log, and maybe a possible error if it couldn't do that. And I'm not going to go over the code. This is using a regular expression, extracting things, converting types. And as I said, this is not the main thing that we're trying to do here. So we are going to gloss over that. The main thing, we have a parse line. Now we can use that. That's what we have. And now we want to go over the lines of code or the files that we have in directory and do that. So I will start with a simple, with the loader, the simple loader. And the simple loader is basically going to do everything that we want. So it's going to load the logs. It is going to return a slice of logs and a possible error. So I'm starting with a new slice, and then I'm using the OS walk. So I need to create a walk function. This function is what is being passed to os.walk. It gets the path to the file, uh, information about the file, and if there was a possible error, calling the file, and if there is an error, I'm maintaining an error. If there is a directory, I'm ignoring the directory. Otherwise, I'm opening the file. I'm using a buffer scanner to go one line after the other, parsing that. And then notice that I'm not returning an error. I'm just going to issue a warning. This is a design decision. You can decide what you want to do, if you want to return an error here or not. And returning error here can be tricky because it's actually inside the walk function. You need to set a global error value. Can be done, but can be tricky. But for me, it's fine. Like every data that you have is going to be dirty in some way. So for me, ignoring lines, it's fine. Maybe you want to say that if it's more than X% of the logs, then we should error, but that's a different story. Okay, and if everything is fine, I'm appending the log, and finally, I'm returning this slice of logs. So this is probably the Go code that you would write before we had iterators, just filling in a slice of logs, going over each file, doing that. Okay, so what I wrote is a loader. Right, so these are the loaders, and in the CMD I have a main function, and this main function is basically going to run one of three versions of this load. We're going to start with the load simple, and this is the load that we have, the one that returns the slice, depending on the name, right? So we have load simples, we have load logs, into other ones, and then we're going to set up logging, we're going to start the time, we're going to call this function, and every time it's going to be a different function, but it does the same thing. It loads every log to us, or returns every log to us. I'm going just to count the logs. So I'm going to over the log and increment the count. I'm going to calculate how much time we did that. And then I'm also going to see how much allocations I did and print out how many logs, how many seconds, and how many megabytes of data we consumed doing that. Okay, in the loader, the simple loader, right? So this is the load logs, and I had to change a little bit the function signature, right, in the loader. So the loader actually calls load simple, which is here, basically just returning a second an error, because all of them other ones returning a sequence. So I'm using slices.values, which turns a collection like a slice into a sequence. Okay, so this is the basic logging, the one that uses a slice, and go run cmd load, and we say that this is simple, right? So this is going to run. It is going to load the logs into memory. It is good exercise for the winter because now my computer is starting to generate heat. And I don't know if you can hear it, but you see we have 11 million and change logs. It took 17 seconds, and we consumed about 4 gigabytes of memory. So, and if you look at the amount of logs on the disk, it's just 1.2 gigabyte. So we consumed about more than 3 times the amount on disk in memory. And this is because when you grow a slice, you grow a lot of intermediate slices. There are many other things that you can do. So this is a big chunk of memory, right? So the question is, why do we really care? Right? Is this big data? Maybe, maybe not, depending on what's happening. Uh, if you're doing this way, and then you need a cloud machine, you need a cloud machine with at least 4 gigabytes of memory. If you can do it with less, you can take a machine with less memory. This is money. So with some simple code, first thing that we're going to gain is way less memory, because we're going to process only one log at a time. The speed is going to be about the same, but the memory consumption, this is going to be great. And it's funny that a lot of time when you look at algorithms and data that you process, you don't need the whole data in memory. A lot of the algorithm, a lot of things that you want, just need a single log or a single record at time in memory, so you can do something to it, and then you move on to the next one. You don't need to, maybe you accumulate how many there are, but in general, you don't need everything in memory to work on them. And a lot of algorithms are like that. So let's look at the sequence. And this is one that is actually going to use an iterator. So what is the sequence? First, we define an iterator over a lines of a file, right? So basically, I'm passing in an IO reader to this sequence, and I'm returning a sequence of strings. So defining a function, right? This is the iterator function. It is getting a function, the yield, which the one that I'm feeding the values, the lines in the file. And this one is going to return me a Boolean telling me whether the iteration is done or not. And I'm going to use a buffer scanner, which allows me to scan one line at a time and yielding them. And again, very typical to iterators, because I'm using sec and not sec2, I'm not returning an error. So if there is an error, remember, if we got the yield before we ended, meaning the for loop has ended, the user has no way to get the error from us. So, and this is, as I said, typical in iterations or in sequences, at least log, right? So I'm going to log that there was an error in the scanning, but apart from that, I'm not returning the error to the user. And then I'm defining another one which iterates over files. So this one is similar to what we did in before, right? So we have the walk function, and then we yield the path, we yield the file, so we go over that. But instead of doing the whole processing, everything in here, we just yield the path. And you see that the code now becomes smaller. Everything is doing something which is very specific and very small. It's easier to debug, and later on we'll see it's also very easy to combine them. So we can do a lot of things with small functions that are working. This one, again, just iterates the file, and then again, if there's an error, I'm just going to log it, and that's it. And now I have the loading of the logs, which is again an iterator, which returns this time a sequence of log values, not of lines. And basically, I'm doing iterate files, and then for every file, I'm opening the file, and then doing iteration of the lines inside the file. I'm passing it, and then if there is an error, again, I'm going to ignore it. In some cases, you can return, as I said, with sec2, you can return an error, or you can return something that said this is an invalid log, maybe add a field to the log saying if it's valid or not valid. I'm just going to warn that there's an error in the log, and then I'm going to yield. But this time I'm yielding, I'm returning to the for loop for the user the log itself. So you see that once I'm starting to think about these sequences of values, I can think of very small functions. One is just doing lines, one is just doing files, and now I can combine them, right? Iterate over the files, iterate over the lines, and then yield outside. And then I have a loader which loads the logs, right? So if I'm going to run with sequence now, the code, it is going to run, as I said, about the same time. And again, it's warming up my machine. I think it's time to buy a new one. Maybe, not sure. Still about 11 million lines, right? Um, so the time is about the same, but single megabyte versus 4 GB. This is a huge, huge reduction in memory. And think about that. If you're running, if you're doing data pipelines and a lot of other things, you just need the records, you push them to the database, you're done. You don't need to load everything into memory in order to pass it to someone else. All right. So this is a sequence, and this is the basic of sequence. And you see now we can break it, but we can break it even more. So when we talk about values or stream of data, we usually talk about three main operations that we can do. One is known as a mapping operation. This means you take a value and you change it either to, in this case, for example, the lower, which takes a string and convert it to a lowercase, or in our case, the log parser that gets a string, which is the line, and returns a log. This is a kind of a mapper. The second one is a filter. And a filter is something that says, you pass it a function, so this is a predicate, and only things that are passing the predicate, I'm going to do that. So if I'm saying that the filter is, I want everything that is bigger or equal to 0, and I have 2, -1, 3, and 4, I'm going to get only 2, 3, and 4. So map and filter are basically building blocks, and once you start thinking like this, this is you start thinking about streams of data, start thinking about how to process them, and this is really interesting. If you remember, when you work with big data, sometimes they talk about map reduce. That's about that. And the last one is a reducer. A reducer gets the whole sequence and returns one value. For example, the sum, or the median, or something like that. So the reducer takes a whole sequence and returns usually a single value. Sometimes if you do a group by operation, it can be something similar. And this is really something that, if you're familiar with SQL or SQL, depending how you pronounce it, is something that you can see, right? So here we have a mapper inside the sum, right? This is the volume times the price, volume or number of shares times the price. We have the filter in the where clause, right? So where the symbol is IBM, and we have the reducer, right? So this is basically, I want the total of money I've invested in IBM. So doing a mapping from taking a row of maybe there is a time and other things inside. I'm just interested in the volume and the price, generating a single value, doing a filter on things, and then doing the sum. Basically, you do first the filter, then the mapper, and then the sum. That's usually the order of things, but not necessarily. All right. So how does it look in the code? So in the code, we can now go to the mapper. And as I said, we can define these functions that there are. So here's a map, right? A mapper gets some type, which is from, so I call it F, and T is to, it converts one from, it gets a sequence of from. So in our case, you can think about getting a sequence of strings, producing a sequence of logs, right? So this is from will be a string, to will be a log, and this is the mapping operation. And then you get the mapper function, the function that actually converts from this type, a string in our case, to a log, right? And the implementation is pretty simple, right? We do a range over the sequence of the values that we need to transform. We transform them using the mapper, and then we yield them out. And that's it. There's not a lot in a mapper, but it's a very powerful tool. Note again that mapper here does not return an error. You can have a mapper that might return an error, and then again, as I said, you can use the sec2, which allows you to return two values. One of them can be an error, or you can, if the mapper fails, you can return an invalid value. And you need to think about what is an invalid value and how do you mark it. It's sometimes not trivial. So this is a mapper, just converting one type or one value to another value, doing some transformation on the data so you can look at that. The second one is the filter. And filter basically gets a sequence of one type because it does not change it, it just removes things from the sequence. And it gets a predicate, which is a function, that tells it is this value okay or this value is not okay. Like in the example we saw, if this value is bigger than 0 or not, and then we do. So again, we do a range. We go over the sequence, the incoming sequence. We say if not the predicate, so the predicate failed, we continue. We ignore the value. Otherwise, we yield the value, always checking to see if the for loop is finished. And now I created another sequence, which is called log lines. So log lines is basically getting the root and just returning strings. Remember, before that, when I work with the sequence, I have load logs, which returns already a sequence of logs, and I did all the iteration and the parsing inside of it. Now, in the mapper, I'm just getting the strings. So the function is even smaller. And this is really nice property of these mappers and reducers and sequences and iterators. You start working with smaller and smaller and smaller functions. They do only one thing. And then you can build one on top of the other because they are sequences. And so I'm iterating the files, and then I'm iterating the lines, and I'm directly yielding the line. I'm not involved in any parsing, right? So this is doing even something more specific, more generic, or actually, which is given a root directory, I'll give you all the lines in that directory, and that's it. That's everything there is. And now I need to create a parse line, which is going to be our mapper. So it gets a line as a string and returns a log, but our mapper cannot fail. Remember, in the mapper, this function does not fail. It always returns a value. So I created this short function that called the parse line that can fail. And if there's an error, I'm returning an empty log. And this signifies on the stream that this was some kind of an error. I couldn't get that. In real application, maybe you want to add the original line to the log, and then you can debug errors and see what's happening. But then our load logs become really, really small function, right? So we have the first one. It is the lines. We can even do lines equal log lines of root, and then we do the sequence, which is map over the lines. So now we have one sequence, which is loading the lines, and second sequence, which is mapping, so converting a string, a line to a log line. And finally, I want to filter out the errors. So I'm using a filter that basically checks if the log time is 0. If the log time is 0, meaning that we failed, this is going to filter out all the bad logs. And you see now I can reuse the sec. So I have one stream, and then I'm combining one over top of it. And you might be familiar with that because we do that a lot with IO readers, right? For example, we have a file which is an IO reader, and then we want to decompress it with, let's say, gzip. We put a gzip reader on top of the file reader, right? So that every time we do read from the gzip reader, it goes to the underlying file and actually gets some data from the disk, decompress it, and return it to you. And the same thing is from these sequences. What we do is pull based, right? Every time Remember, when we do all of this code, nothing happens. We just return functions. These functions haven't done anything yet. Only when someone runs the first iteration of a for loop on load logs, this is the time that you can actually going to the disk, iterating over the file system, opening a file and returning the first line in the file. But before that, no code is running. There's nothing happening with the code, right? So load logs now, it's very short, right? Uh, and I created this predicate function uh, on the fly. This is also something that is pretty familiar because a lot of time to filters and mappers, the uh, functions you pass are pretty simple. I can even get rid of pass line, right, and put it directly here as an anonymous function. This is also fine, and you're going to see it a lot. This is starting to look like functional programming, which I would say Go is not ideal for, but with these sequences, this is pretty nice. Okay, and then in our code now, we can call with the mapper, and we're going to run it. And again, this is loading 11 million in chunk lines of code using a regular expression, convert it to a log. But this time it's doing it with streams. One is generating lines, one is converting to logs, one is filtering out empty logs. Uh, we see the time a bit slower, but when you're doing time measurement on your laptop, when you're broadcasting video, this is not the right thing. So I'll take it with a grain of salt. But we're still keeping the 1 megabyte memory, which is pretty awesome, right? Comparing to the 4 gigabyte before, and the code now is much cleaner. It's much nicer. It's smaller. Everything is doing just a single thing. It's easier to debug. I can now write small unit tests for each part of the code. This is pretty nice. All right. So I don't see any questions. Are these code in some public repo? Yes, it is in a public repository. I'm going to post the link at the end of the slides. You will be able to have a look and see that. Okay, so this is the part of loading the loads, the logs, but we want to query them as well. And I was thinking about, okay, I want to expose it as a web API because why not? Um, this is the usual way. Once you expose a web API with JSON, anyone can talk to it, and it's not a problem. So what I'm going to use something known as Cell, CEL, Cell. Cell is a language for querying. So you can write some queries in Cell, and then the user can write things like account.balance is bigger than transaction.withdrawal, and Cell is going to evaluate that and return some data to you. I'm not a really big expert in Cell. I'm using it in current project and I like it. And of course, it has an implementation in Go. So that's what we're going to do. We are going to use Cell to query. The user is going to specify a Cell expression saying, I want the status to be, let's say I want to find the error, so I think that is bigger or equal to 400. And then we're going to do that. The other thing is that I'm going to broadcast or send the data over HTTP. Now, I don't want to have all the fun of loading just a single record at a time to the web server, but then accumulate everything in the web server and then send it as a big chunk of data outside. Because that's, I did half of the work. Why can't I do the rest of it? And lucky for us, we have a solution for that. In the HTTP protocol, there's something known as a chunked encoding. Chunked encoding is basically saying that the web server is not sending the whole document. It is going to send the document in chunks. And before every chunk, it's going to write how many bytes, and then the chunk, and how many bytes, and then the chunk. And eventually, it's going to do a sentinel with 0, and then you know that the data is there. And the server is not going to write you the content length. Um, so we are going to utilize that. And on top of that, what we're going to do is we're going to send one JSON, one record as a JSON as a single line. And this format sometimes known as JSON lines or ND, new line delimited JSON. Uh, Both of them are the same thing, basically. One JSON record per line. There's a new line between them. The nice thing about JSON lines is that, again, that you can send one after the other, but someone on the other side need to know that you're sending them. So if you're working with the JSON decoder from the standard library, it's already possible to do that without doing anything. So you just create a new decoder on top of the HTTP response body. And then you read one record, you do decode, and then again decode, and it will give you everything. But if you're working with other languages, they might need to know that, and they might need to know that you read the line, you pass JSON. You read the line, you pass JSON, because a lot of JSON lines together are not a valid JSON document. Um, um, okay. So let's have a look at the code. Before that, any resources for functional programming? Nothing on top of my mind. Sorry. And then Muhammad is saying that the fact that these new features sometimes change the nature of Go. I agree, right? There's been libraries like the functional one. Oh, forgot the name. For Go. Oh, blackout. And it's not like looks like an idiomatic Go code, and I agree with you. But in another way, in any language, you can program in a lot of ways that do not look really like the language, and the language is evolving. We have generics now. We have other things. I don't think it's going to be mainstream. I don't think a lot of people are going to do functional programming in Go. So I think it is a feature that you can utilize, as you see, to reduce memory by a lot. And then we'll see. The Go team is saying, well, we're giving you the tools, we see what the community is doing, and then we adapt. So that's what's going to happen, I think. I'm not familiar with FP Go. I'm familiar with another one. It's modeled after a JavaScript one. I forgot the name. But this one is not working. It came before we had iterators, so I'm not sure. So many packages coming out. Go is becoming so popular. It is awesome. All right, so let's look at our HTTP server. So we can close you, and this is the HTTP server. Right. So first, I'm going to talk about a little bit about the working with cell. Right. So basically, what you need is a cell environment, and this environment you define what are the variables, basically what are inside the log record. So I'm saying that I have an environment where I get the host, the time, the request, the status, and the length. Right. And if we look at the parser, where are you, parser? Right. These are pretty similar to what we have here, right? The host, the time, the request, the status. I changed bytes is a reserved word in cell, so I can't use that. So I convert it to length. So we can have. So on the init, which is running before before your code is running before main, I'm creating the environment. And in init, we can't return errors. So if there's something wrong here, I'm just panicking. You can probably do it in main and then catch an error, but that is really up to you. And then I have a function to convert a log to a map, because Cell is working with maps. So I'm turning the log record, right? So host, time, status, and as I said, bytes is going to be called length. And now this is the function that creates a filter. So it gets the expression. This is the expression that the user is sending. And then it is compiling the expression. This is what the environment is doing. And if there is an issue, I'm returning an error. And then I'm creating what is known as a cell program. And now I have this program. Now I can create my predicate. And this is one that is going to be in the filter, right? So this is the predicate that I'm using. It is getting a log and returning a Boolean saying, does it match the predicate or not, right? So I'm converting the log to a map. Then I'm calling eval on the record. And calling eval basically is going to execute this expression the user gave. And our expressions are supposed to be filtered, so I'm assuming it's a Boolean value. So I'm returning a Boolean value and returning it. And that's it. I'm returning the function and I'm done. So this is basically the filter in cell. Not a lot of code, but a lot of power, because now I don't need to write my own parser. I don't need to think about syntax and writing languages. It's not easy. So that's what we're doing. All right. So now we have our main, and actually I wrote another one, another sequence that gets one sequence and returns another. This is the limiter. So the user can say, I want this filter, but I want also only 10 results or only 20 results, depending on what I want. So the limiter basically gets a sequence and an integer saying, this is how many records I want from that sequence, and returns a new sequence. And then you start with 0, you yield until you get to the number, and then you quit. And now we have the HTTP handler. So the HTTP handler, first thing that happens, we load the logs. Now, what's really nice about that, it doesn't do anything. Remember, sequences, iterators are lazy. So I'm just getting back a function. I didn't call this function. I didn't do any access to the drive. I didn't do anything. So if there are errors here, no resources that I need to filter, clear, nothing happened. I can do an error. Second one is I'm getting the query from the user. So the user is passing in as a filter HTTP argument. And if I'm getting this expression, I'm creating a filter. And then you see I'm combining, I had the logs here. This is all the logs that are coming in. Now I have this filter about filtering out the logs. And the user can specify, the user can omit the filter, and then they're going to get the whole logs. The second thing that I'm doing is I'm doing the query. So, the limit. And then the user can say, okay, I want everything that is bigger than bigger or equal to 400, but I want only 10 of these. And if this is happening, I'm doing the logs. Now note that here the order is really important. If I was doing first the limit and then the filter, the limit was giving me only the first 10 records, whether they're matching the filter or not. And on that, I was doing the filter. So every time you combine these sequences, you really need to think about the order and what makes sense. You want first filter, so getting only the records that match this predicate, and then out of them, I actually want only 10 or not. Because if you do it the other way around, it meaning I just want any first 10 records, and on them you're going to do the filter, there's a good chance you're not going to get anything out. Right. Once we have that, I'm setting the header, and I'm creating a new response controller. This is what allows me to do chunked encoding on the side, on the Go server, right? And I'm creating a JSON encoder, and this is the JSON encoder. I said the JSON decoder can work with JSON lines, the JSON encoder as well. JSON encoder, if you encode again and again with the same encoder, it is going to emit one JSON per line, which is pretty awesome. Right, so now I'm running the for loop, and this is the first time that actually something is going to happen. So once I'm doing the for loop, this limit is going to say, hey, I need the log to see if you're there, and it's going to call the underlying logs, which is the filter, and the filter is going to say, hey, I need a log in order to check if it matches the query or not, and then it is going to call these logs that is going to go to the disk, going to go to the files, and going to iterate the lines, etc., etc. So until we got to here, until we do the first iteration of the for loop, nothing really happens in in terms of accessing the log files, which is, I think it's pretty awesome. And now we encode the again using log map, encoding the log using the JSON encoder, and then if there is an error, we are just going to say there is an error, and now I'm going to return from our handler. Now the thing that is important is to do the flush. The flush from the controller, the HTTP response controller, is the one that is going to immediately send the current data. And this is once the controller does the first flush, it says, okay, this is now a chunked encoding, and now we're going to run it. Why aren't you happy with main? I really don't know. Okay. So I'm creating a new server, a new MAX, which is the router. I'm saying get logs is the logs handler. I'm going to say that we are doing the address and the handler. We're going to start the server, and that's it. So why aren't you happy with main? Expected. What did I do? Are you happy now? No, now we're happy. Okay. So I probably touched something I shouldn't have done. These are the kinds of whys, and then you sit for an hour and don't understand why. Okay. So I didn't mean that you should defer the flash. I mean that once there is a flash, what the response controller is going to do is say, okay, now I know that you're doing chunked encoding. It's going to take the first chunk of data, set the header to HTTP chunk, and then write the data. And then again and again and again, it's going to write how many bytes and write the data. We're going to see it in a little bit. All right. So go run /cmd httpd. So this is the server. And because I'm old, I wrote it in a makefile. Right, so this is the query that we're going to do. We're going to use CRL, the CRL client. -I tells it to show also the headers that are being sent from the client. Raw is going to tell it, I want to see the raw data that's coming in, not the finalized HTTP response. And then you see, we say the limit is 10 and the filter is status. And this is the encoding of bigger equal in HTTP. Right, so I need another one, right? And then now, you know what? I need you bigger. I can do make query, and now you see what happens. By the way, you see how fast it was, right? Because it didn't go over everything to find. It didn't load everything into memory. Just bring out lines, ones that matching the predicate, and we see that you see this is chunked encoding. This is what we get, and this is the size in hexadecimal, and then we get the first one, and then we get the second one, etc., 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 and we got only 10 of these, right? So from the beginning of the data, from the disk until the client, we only operate in one single line level, which I think is pretty awesome, right? The data can be huge. We saw that we have 11 million lines, but we just work with a single line at a time. All right. We have some time for questions, so if you write them in the chat, I will try to answer them. Right. Before we go to that, can you show my screen one more time? Right. So this is where the code is. If you want, you can use the QR code and just see that. This is where the code with my other talks. So someone asked about the code. This is there. Okay, now I'm ready for questions. When there are no questions, I'm always wondering whether it was too simple or too complex. What happens if you call the URL in the browser? You're going to see a So if you're doing, let me go to the make file just a second. Oh, I need to make this one. So let me just, so if I'm going to do it like this without the raw, or without the I in the raw, this is basically what the browser is going to do. Query, query one. Ah, I hate query one, but make query. So this is what the browser is going to see. It's just going to see a bunch of all of these. Not sure how it's going to interpret that, but basically it looks like, text document that's coming in. It's probably going to say, I'm not sure about this this MIME type, this content type, so it doesn't show what to do. At which point you have to create a yield function. Yield function is provided by the Go compiler. This is not something that you do. The yield function is basically Go telling you, you just generate the values and then you pass them to me, and I'm going to pass them to the user, right? For example, if you look at what you have when we do the iterate over files, here, iterate over files, right? So when we do os.walk, where is the os.walk? Here. When we do os.walk, we pass it a function, right? So we create a function, this is the walk function, and then we pass it to os.walk. And that's basically what the Go compiler is doing for you. So you don't need to take this function and passing it. Basically, this is like reversing the order of how things are doing. Instead of someone pushing, giving you a function to work with, saying do this or do that, every time you basically just yield the value, and then it passes to the user. If the user want to print it, they can print it. If they want to save it to a file, they can save it to a file. If they want to calculate the length, they can do that. You don't care. As a generator or a sequence, you just produce values and give them to the yield function. After that, it's out of your hands. Does other labs have any OS project that someone might participate? We have the something for conf, which is passing configuration. You can have a look at that. Yeah, so the Go compiler is passing the yield function. The yield function is something that you don't care. This is Go saying, once you produce the value, give it to the yield function, I'll take it from you. All right, so we have more courses, Practical Go Foundations. If you're starting with Go, I just redid it. More modern Go, it's nicer. We have the Ultimate Go bundle and performance, and many other things. You're more than welcome to visit the Arden store and see them. And thank you very much for your time.